Whether you need to diagnose something or you want to replace the unit entirely, or you just like learning about RV systems, today I'm going to show you everything you need to know about the 12-volt RV head unit. I installed my first 12-volt head unit in 1994. In 2001, I opened an automotive electronics store. I've probably installed at least 1,000 of these things since then. So before we start learning what all of those wires do, there are 3 general rules I want to go over now so everyone watching this video understands and I don't have to keep repeating them throughout the video. There are some RVs with 110-volt audio systems, but today we're covering 12-volt DC-powered head units, and that's probably what 99% of you watching this video have in your RV. Second, you may hear me mention the term car audio throughout the video, but don't get confused. The stereo system in your car, for the most part, operates the same way as the stereo system in your RV. And the third and last ground rule I want to cover today is among the 12-volt audio manufacturing industry, there is a standardized color chart. Those colors will apply to the wires on the majority of head units on the road today. However, if you do see something that looks a little bit strange, you can go ahead and look for a label somewhere on your head unit. You can always meter test the wire, and if you still can't figure it out, just leave me a question down in the comments section. Now, some RV manufacturers unfortunately don't do a great job of connecting these wires properly, so I would advise disconnecting power to your head unit before you pull it out to avoid any short circuits. I would start by disconnecting your 12-volt battery. If you still have power at the head unit after that, it's because your converter is still powering the head unit, so you'll want to disconnect your shore power. Once you know the connections are good, disconnecting the power is not really something you need to do every time, but I would advise doing it the first time, and I'm going to show you how to properly connect these wires a little bit later in the video. These are always more difficult to remove in cars because they usually require removing dash panels, and some even require specialty tools. However, in an RV, they're usually just screwed in, and if you don't see any screws, you just have to pull some panels off. On my unit, this bottom panel just pops off, and you'll see 4 screws, 2 on each side. Once you get the head unit out, you're going to see a bunch of wires. Now, I've been holding back for a long time from redoing these wires myself, but I want to show you guys what to expect from the factory. Some of these connections are made with electrical tape, some are made with crimped wire nuts. Definitely a lot of inconsistencies here, but we'll talk about that a little bit later. Most of the time, these wires will run into harnesses that unplug from the head unit itself. And all of these wires are either input or output wires. I'll explain that as we go. So let's start with the power wires. You're going to find a black wire, a yellow wire, and a red wire, and these are almost always found in the same harness. Most of you probably already know 12-volt DC is really simple. There's a power or positive side, and there's a negative and a ground side. Let's start with the easiest wire to understand in this whole video. It's the black wire. This is your ground wire, also known as a chassis ground or a 12-volt negative. You want to keep these as short as possible, and that chassis ground will eventually connect to the negative terminal on your battery. This black wire is an input wire, meaning you need to put negative 12 volts into this wire for the head unit to work. Okay, let's move over to the power wires. You have a yellow wire and a red wire. So you may be asking, this is a 12-volt system. There's a power and a ground. Why do we have 2 power wires? I'll explain that in a second, but let's start with the yellow wire. The yellow wire is called a constant power wire. This is also an input wire, meaning you need to put 12 volts positive into this wire all the time. That's why it's called a constant 12-volt power wire. Your head unit has settings like bass and treble that you change and customize. It also has things like radio stations that you program in. For the head unit to remember all those different settings and radio stations, it needs to see constant power all the time. Even when you push the button that turns off the power to the head unit, there's still positive voltage going through this wire to hold on to and maintain all of those settings. You've probably experienced losing power to the constant power wire before. If you've ever had your battery changed in your car, you get back in and you notice all your radio stations are gone. That's because the battery was disconnected, meaning this wire lost power. It's also important to point out that in most cases, all the things inside the head unit that require power to operate, like the amplifier or the lights on the display, get their usable power from this 12-volt yellow constant power wire. And because this yellow constant power wire provides all the usable power for the head unit, you're usually going to see this fused. Sometimes the fuse is actually on the body of the head unit. However, with the yellow wire connected to 12-volt positive, and the ground wire connected to 12 volt negative, your head unit is still not going to turn on. Enter the red wire, also known as your turn on power or your accessory power. So if you remember earlier, I said the head unit in your RV is essentially the same thing as the head unit in your car. So when you get in your car, turn the key on, a relay will send power to this red wire and it will tell the head unit it is now allowed to turn on. When you turn the key off, or nowadays when you open the door, that relay kills power to this red wire and your head unit will automatically turn off. That is the only purpose of this red wire. It's essentially a trigger wire. When it sees power, it allows you to turn on and use your head unit. Technically, there is no use for the red wire in an RV. The head unit still needs to see power through this red wire, but you can usually just connect the red and yellow wires together, and you'll probably see that done already from the RV manufacturer. Now that you understand why there's 3 power wires on what is normally a 2-wired 12-volt system, let's move over to the speaker wires. Speaker wires come in pairs, and just like a 12-volt powered device, they require a positive wire and a negative wire to work. The positive side for our speaker wires are one of 4 colors, either white, gray, green, or purple. The negative speaker wire is the same corresponding color, except it will have a black stripe. For example, the green wire and the green wire with the black stripe will be designated for one speaker. Speaker wires are not input wires, they are output wires, and if you haven't figured it out already, it's because they push voltage out of the head unit to the speaker. A highly simplified description of what happens is this. The positive wire provides positive voltage that moves the speaker cone one way. The negative voltage moves the cone the other way. When the cone moves, that creates a sound wave, and that's what you hear. Each color designates a very specific location. In a car, the white is the front driver's side, gray is the front passenger side, green is the rear driver's side, and purple is the rear passenger side. The colors are extremely important because music and movies are recorded in stereo. So what you hear on the left side is not always what you hear on the right side. This is called balance. Similar to balance, most head units also give you the ability to fade front to back, meaning you can increase or decrease the sound to the front or rear of the car. This is called your fader. Now in RVs, this is a little bit different. There's not really a front and a back. So think of the front and the back as the inside speakers and the outside speakers. But this is still essentially a fader. You'll want the inside speakers to draw from the front left and front right channels, which are whites and grays, and the outside speakers to draw from the rear left and rear right channels, which are the greens and purples. Okay, now that you know which speakers get which wire colors, let's talk about the importance of properly connecting those wires to the speakers. I see it all the time, posts online where people saying it doesn't matter which wire goes to which terminal on the speaker, but it definitely does matter. When you connect the wrong wire to the wrong speaker terminal, it reverses the polarity of the speaker. So what this means is when a speaker cone is supposed to push out to create sound waves, reversing the polarity will force the speaker in. It's usually not a big deal if all the speakers are wired the same way. However, if you have one speaker wired in correct polarity and one other speaker wired in reverse polarity, they sort of cancel each other out and it's going to make things sound really weird. The way to get the best sound out of your speakers is to make sure you're connecting the positive speaker wire to the positive terminal on the speaker and the negative speaker wire to the negative terminal on the speaker. Now we need to just identify which terminals are which on the speaker. First, look at the terminal. Sometimes they'll be labeled with a plus or minus for positive and negative respectively. If you don't see labels stamped into the terminals, just look at the size of the terminals. If one is larger than the other, the larger terminal is usually the positive terminal. Now, if neither are labeled and they're the same size, or you just want to confirm for yourself, grab a 9-volt battery and touch the battery leads to the terminals. If the speaker pushes out, the positive terminal of the 9-volt battery is touching the positive terminal of the speaker. If it pulls in, the positive battery terminal is touching the negative speaker terminal. So as I'm editing this video, I'm realizing some of you may be wondering why I'm talking about speaker polarity in a head unit video. The manufacturer has already run wires from the speakers over to the area behind the head unit, right? This is true, but it can't hurt to just check to make sure the manufacturer got the polarity correct. And if you ever replace a speaker, don't count on the manufacturer using the correct wire colors for the speakers in the ceiling. It just can't hurt to check for yourself. And that is the speaker wiring on a 12-volt head unit. Let's move over to the rest of the wiring. Sticking with single wires, you may see some other colors. Let's start with an orange wire. This is usually going to be an illumination wire. In an automobile, this connects to the vehicle's illumination wire, and it will dim the display of the head unit when you turn your headlight headlights on or off in the vehicle. There really is no need for the orange illumination wire in an RV application, so this wire can be left disconnected. You may also see two blue wires. One is going to be a solid blue wire and one is going to be blue with a white stripe. Let's start with the blue wire. This is what's called a power antenna wire. A few years back, cars used to have antennas that went up or down when you turn the radio on or off. If you've been around long enough, you've probably lost a power antenna in an automatic car wash. So this blue wire will send voltage to the power antenna motor, which will raise the antenna when you turn the radio on. When you turn the radio off, this wire loses voltage and the antenna would lower. Let's move over to the blue wire with the white stripe. It basically does the same thing, but there is a little bit of a difference. This wire is called the remote turn-on wire, sometimes also called an amplifier turn-on. In the car audio world, this wire will provide voltage to open a switch that will allow power to something like an external amplifier or other powered equipment. So if you're a little confused, I'll make it really simple for you. Think of these two wires as your finger on a light switch. The power the light bulb needs is coming from another source and is already run up to the switch. But that switch is off, so the light bulb is not getting that power. You flip the switch with your finger and it allows the power to go through the switch to the light bulb. That's what these wires do. They act as a finger to open a switch that allows a different power source through. The blue wire, or the power antenna wire, will only supply voltage when the head unit is turned on and you are listening to the AM or FM radio source. When you switch off of the radio to another source, for example like the CD player, this wire loses voltage. On the contrary, the blue wire with the white stripe will provide voltage as long as the head unit is turned on, regardless of the source you're listening to. The amount of current going through either the blue wire or the blue wire with the white stripe is very minimal. These wires should only ever be used as a trigger to open a relay or a switch to allow power through to turn something else on. We have never charged a membership fee for our viewers to watch any of our videos. All of our content is always free. We work with our channel sponsors to keep the lights on, so there's never a cost to you. So I would like to thank today's video sponsor, RVmattress.com. They have a nice selection, mattresses for all budgets, and they have the oddball RV sizes that you won't find in a residential mattress store. You'll find the RV bunk, 3 different RV king sizes, and the short queen, among others. Their website will point you to the right mattress based on how you sleep. Shipping is free. They come with a 10-year warranty, and they have a factory right here in Arizona. If you don't like your mattress, you can return it or exchange it for a different model within 120 days. And honestly, guys, we loved our mattress so much, we got another one for our house. Visit rvmattress.com/RV tips. I'll put links down below. Use the coupon code RV tips at checkout and get 25% off your mattress. The single wires we've covered up to this point are what the majority of you are going to see. However, you still may find some different color wires like a pink or a brown wire, but most of these wires will be 1, labeled, and number 2, not necessary for an RV application. Now, before we move over to wires that have plugs on them, let me show you how to properly connect single bare wires together. I know I've seen a few folks just take the ends of the wire, twist them together, and then wrap that up in electric tape, and that's really not the best way to do it. Electric tape is a good temporary insulator. However, in the high heat applications that the inside of your RV sees, especially when it's not being used, that electric tape can get a little bit gooey and start to slide off the wires over time. The crimpable wire nuts that the RV manufacturer used on my head unit from the factory is not really the right way to do it either. The most secure way to connect wires in a 12 volt or low voltage application is to solder them together and then insulate them using a heat shrink sleeve. But that can be a little bit difficult in an area where you don't have the luxury to use a bench and a helping hands device. A crimpable butt connector is quick, it creates a solid connection, and you won't have to worry about anything shorting out later. Plus, they're really easy to use when you're working in an application where you have to do the connection on site. You can pick up one of these butt connector kits. These are nice to have in case you need to make a wire repair while you're on the road. I'll put links to this down below. Just select the size connector you need based on your wire size, slide the wires in each end, crimp them together, and then use a heat gun to heat shrink the insulator. If you don't carry a heat gun with you on the road, a hairdryer will also work in a pinch. It just takes a little bit longer. And that's it. You have a solid connection that is well insulated, and you'll never have to worry about that connection again. And if you have to rewire something, just make sure that you're using the correct wire gauge. I'll put a link to a downloadable speaker wire gauge chart down below. Okay, let's move from bare single wires over to multi-wire cables, which will almost always have a plug on the end. On the back of the head unit, usually on one of the 4 corners, you'll see this large metal plug. It's the same concept as the AM/FM antenna on your car, and these will usually plug directly into the body of the head unit. Sometimes you will find a short lead coming off the head unit, but these are really easy to identify. One side is male, the other side is female, and they just plug together. The rest of the wires are going to mostly consist of RCA style plugs. You may also see some HDMI plugs as well. RCA and HDMI plugs will almost always have a label telling you what they're for, wrapped right around the wire or somewhere on the head unit. Let's first cover RCA cables, which look like this. They are either male or female. Unless you're living under a rock, you've probably seen these before. They will almost always be red, black, or white, which are audio RCAs, and if you see a yellow RCA, it's almost always going to be a video RCA. Audio RCAs, when they're labeled, are going to say audio out or audio in. So you may be wondering, what's the difference between an audio RCA output versus speaker wire outputs? Speaker wires are designed to connect to raw speakers. RCA outputs connect to something that is designed to accept RCA plugs, like a soundbar, for example. Now, most soundbars are Bluetooth compatible. However, if your head unit is not Bluetooth capable, you're going to need to run audio from the head unit over to the soundbar, and to do that, you'll just run the audio from the RCA outputs here to the RCA inputs on the soundbar. Moving over to RCA audio inputs, these wires will accept an audio input from a completely different source, run it through the head unit, and then out to your speakers. A perfect example of using RCA audio inputs would be running the audio from your TV down into your head unit. Many of you may have noticed that if you're watching cable or satellite TV from the campground hookup, or you have a streaming stick plugged into your TV, you only hear audio through the speakers of the TV. That's because the audio is originating at the TV and not the head unit, so it has no way of getting out to the speakers in your RV. So a really quick modification you can do is run a pair of RCA cables from the television's audio outputs to the audio RCA inputs on the head unit. Then, when watching cable, satellite, or a streaming stick in your RV, just switch the head unit source over to the auxiliary audio in, and you'll be able to hear the audio from that feed through your speakers. I'll put a link to that video at the end of this video. So that's audio RCAs. Let's move over to video RCAs. Video RCAs are almost always yellow. If your head unit has a built-in DVD player, it will always have a video output RCA. The yellow RCA video output will be run from the head unit over to your TV's video input. Okay, what about a yellow video input wire? Unless this head unit has a screen built into it, you'll have no reason to run video into this unit, so you'll most likely never see a yellow RCA video input on the back of your head unit. And that's it for audio and video RCA wires. You may also see an HDMI wire, which most of you are probably familiar with from connecting electronics at home. An HDMI cable gives you the ability to run multiple audio channels along with a video signal in one cable. If you have an HDMI output on the back of your head unit, you can run that directly over to the HDMI input on your TV. But again, audio and video, either in the form of RCA or HDMI, will already be run from the factory when you get your RV. But it is worth knowing this in case you need to replace one of these components or you need to rewire something. Okay, let's cover some miscellaneous wiring that you may see. Sometimes on the front of the head unit or even the back of the head unit, you may find a series of small plugs. This is usually a 3.5mm stereo jack, and this can be an input or output audio line. If it's an input line, you could plug something else into this head unit, like a cell phone, for example, and the audio from the cell phone will run through the head unit and out to your speakers. If it's a 3.5mm audio output, you could plug something into that plug and hear the audio, for example, in headphones that's originating from the head unit. You may also see something else on the back of your head unit called an IR remote jack. This will just give you the ability to place an IR remote eye so you can use the remote control somewhere other than pointing it directly at the head unit. So for example, if you're outside and you want to be able to control the head unit using the remote from outside, you would plug in an IR remote eye and mount it somewhere on the outside of your RV. You point the remote right at that eye and it will control everything inside the RV. And that's a summary of the wiring the vast majority of you guys are going to see on your RV head unit. Okay, you've learned what all of these different wire colors mean. Now you need to test or diagnose something. All you're going to need is a multimeter, and it's pretty straightforward. You will need to have your meter set to 12 volts DC. If you're testing for positive voltage, you will need to have your black lead on a good known ground. And if you're testing for ground, you will need to have your positive meter lead on a 12 volt power source. So here is my 12 volt yellow constant along with my ground. I'll connect my leads and you'll see 12 volts on the meter. That is all you're going to need to do to test any of the power wires on this head unit. Now, if you want to test speaker wires, the best way to do this, guys, is just connect your speaker wire outputs to a speaker that you know works. If you need to replace your speakers, make sure you get a speaker with an ohm rating that matches your head unit's ohm rating. Okay, hold up. what are ohms and why haven't they been mentioned in this video? I'm going to make it really simple. The common impedance for most 12 volt head units is usually 4 ohms. So when buying an aftermarket speaker for your RV, get a 4 ohm speaker. Most speakers will tell you the impedance in the description of the speaker, but if you buy a full range car audio speaker, it will most likely be 4 ohms. There are very few exceptions, and you should always confirm for yourself the impedance on your speaker and the impedance on your head unit. But most of the time, you're going to be dealing with 4 ohms. Now, what if something doesn't test out or meter and something stops working? I'm not going to say there's not 12 volt audio repair shops still in business. In today's economy, you'll have probably most of the cost of a new one into diagnosing and repairing an old one. And that's if you can find someone to do it. Now, I'm not saying they don't exist, but I'm confident in saying these are usually throwaway units once they stop working. You can always contact the manufacturer and see if they want you to send it back to be repaired, but I wouldn't be surprised if they just told you to replace it. As I mentioned earlier, I'll put a link on the screen right now to a video that shows you how to get all audio sources to the speakers in your RV. I hope you learned something from the video. A few of you have been asking for this video for about 2 years now, but there's just a lot of wires. But if you have additional questions, just leave them in the comments down below. Please like and subscribe, and we'll see you in the next video.